Okay, what I want to talk about today is the beginning sequence of A to N. And before I begin my talk, I want to two volunteers. And to be justice, I need two numbers. One is A, and one is B. They are all positive integers. So, Professor Lind, could you give me a positive integers and
two.
1010. 1010. So with these two numbers, sometimes we may wonder whether there exists such a n, so that 2 to n is the beginning of 2 to n is, and even more, will there exist n prime? So if you study the beginning of this number is, and this is what I want to talk about today. And actually, I have found something very interesting about first some digits of the power n of the positive integer a. And first, see an example of the power of 2. Okay, from this we can find the first digit is 2, 4, 8, 3, 6, 1, 2, 5, 1, 2. And these are the first two digits. Now observation. We find there are most 1 and 2. There are 3 2s and 3 1s. And other numbers just ones. But there is no 7 and 9. And for the first two digits, these numbers are all different. So we may have some questions. Will there appear 7 or 9 when n becomes larger? Or why are there most 1s and 2s? Will there appear up to digit numbers when n becomes larger? And what about 3-digit numbers? What about big-digit numbers? And or even more crazy, what about powers of any other number? And what will appear in the beginning of the powers of these numbers? Now the first question is very easy to answer. By using the calculator, we can get 2 to 46 is begin with 7, and 2 to 53. The meaning of 2 to 53 is 9. Now, if the question 2 is alone, we just focus on the last two questions, which are the basis questions of the question 3 to question 4. Before solving these questions, we see another example, the power of 3. And from the list, the first one digit is 3, 9, 2, 8, 2, 7, 2, 6, 1, 5, 1. And these are the first two digits. Now, so we can find that there are most 2s and 1s again. There are 3 2s and 2 1s, and almost all numbers except 4. And these are the first two digits. So now we may think the power through these two examples, we may assume that it's also true for the power of 4, 5, 6, etc. That will appear any kind of 1 or 2 digits in the beginning. But what about 10? Okay. When the number is 10, the first one digit is always 1, and the first two digits are always 10. It's strange. And more generally, it's easy to find for any 10 to n, also including 1. The first digits of the power are always 1, and they're also the same, not changed. But besides these spatial numbers, we have no idea about what will happen for other numbers. It seems that there will happen any kind of number sequence in the beginning of the power of some other number. So my main result is for any positive integer a, which is not in the form of 10 to n, for any b, which is some number sequence, there must exist n and omega. which are natural numbers, so that satisfy this n equation. Also, we can also say for any positive integer a, which is not in the form of 10 to n, there will appear any kind of number sequences in the beginning of some power n of n. Now that we prove it. To prove this, we need theorem 1, and this is theorem 1. I'll explain it. What does that mean? If this is a circle, and this is 0, or it's 1, and alpha is irrational, and when we start from here, and every time we move alpha, and after n movements or more, there will, for any interval in this circle, there will be some point that is the point after some movements and get into it. And then we will use this theorem. And now let's focus on this equation, and then we will know why we need this such one. Let B, A is any given positive integer, and B is any arbitrary number sequence, which does not begin with 0. And this bracket means the fraction part, and